Okay, so what we've done so far, which is SOHCAHTOA and Pythagorean theorem, can only be used with right angle triangles. But life is not easy, and we don't always have right angle triangles. That's why we have other formulas to use when we don't have right angle triangles. And these formulas, so the goal for today's lesson, or for the sine law lesson, is to find the measure of sides and angles, but this time in triangles. Okay? So these are triangles that are not 90 degrees. An oblique triangle is any triangle that does not have, I just said it.
A right angle.
Yes. Angles are across from their corresponding sides, right? So whenever I'm naming the triangle, always remember angle A, side A. Angle B, side B. So the side across from it has the letter that belongs to it. Correspond. Tell Dominic to leave. Thank you. Okay. So there are two conditions to use the sine. Okay. So you need to know two angles and any side. So if you know two angles and any side, you can use the sine law. Okay? Now, remember that when I know two angles, I can find a third in case I need it, right? Because let's say if I give you this. I gave you this angle, right, which is, let's say, 20, and I gave you this side. Let's say this is 10, and I gave you this angle here, which is 80, right? Let's say I gave you this. So in this case, I can't do this triangle using the sine law because I always need an angle and its opposite side, right? So the only angle and opposite side would be this. Right? So, but remember, I have two. I can find this angle easily by doing 180 minus 80 minus 20. Okay? So as long as you have two angles, you can always find the third angle if needed.
Add 2 and minus by 180.
Sorry?
Add 2 and minus by 180.
You do 180 minus, yeah, add the 2 and then subtract from my 180. Yeah. So that's why it says here, use the sum of angles to find the third angle, and that's if needed only. Okay? If you're finding the side, you're going to use the formula. Do you guys remember what the sine law formula is? What is it?
A over sine A.
A over sine A
B over sine B.
equals to B over sine B.
Equals to C over sine A.
Yes. And remember, guys, that the letters can be anything. They can be like x over sine x, z over sine z, y over sine y. Doesn't matter, right? As long as they're the matching letters. A sine A. Okay? And you only use two ratios at a time. So if you know A and B, you're going to only use A and B. If you know B and C, you're going to only use B and C. If you know A and C, you're going to only use A and C. Okay? Formulas will be given to you on the test, so you don't need to memorize them, but it's good to know how to use them, right? Now, the other condition is if you know two sides, but in this case, you have to be careful. You need to know one opposite angle, okay? So the angle has to be an opposite to one of the sides that are given. There's no S. So in this case, I know this angle and I know this side. Okay? I know this side and I'm looking for angle A. Okay? So I have B and I have A I'm looking for angle A. Okay? Because I'm looking for the angle, the formula that I've seen here is the same, but it kind of switches. Okay? So because I'm looking for the angle, the formula becomes sine A over A equal to sine B over B equal to sine C over C. Just to make things easier for you to solve. Okay? So if you're looking for the angle, you're going to use this formula. If you're looking for the side, you're going to use the top formula. Again, you're only using two of the ratios at a time. Was Sarah screaming at someone? I don't know where she is. Okay, so this is asking you to find the length of side D. So you're looking for this side. What do I know?
Two angles on a side.
Okay, I know two angles and a side. That's good. Because if I know two angles and a side, that's sine law. Right? Because that's one of the rules. Now, look here. I have an angle and its opposite side. And I know this angle and I'm looking for its opposite side. This is important for sine law. Otherwise, you can't use it. All right? So, in this case, I do, what would I write since I'm finding
D over sine 40 degrees
So, sine big D, yeah?
was E over sine capital E.
E over sine A.
Big
Okay?
B.
Hmm?
Big E.
Capital E, yeah? All right, now, I don't know what side D is. Over sine 40 equal to, I know E, which is 38, over
Sine 95.
sine 95. Okay, you see how now it's easy to solve for D because it's on the top, right? That's why I have to pick this formula. Now, all what you have to do is half cross multiply. So you're going to multiply the sine 40 by the 38 and then still divide by sine 95. So you're only multiplying the sine 40 by the 30 and leaving D on this side by the 38. And then dividing by sine 95. What does that give you? Sorry? 24.5. And that's going to be in centimeters.
Oh.
Now, what do I have? I'm looking for angle C. What do I have in this case?
Find the angle. So
I
you have two sides of the angle.
have two sides of an angle. I have an opposite angle, right? So I have two opposites. And I'm looking for, I have this side, I'm looking for angle C. So, because I'm looking for an angle, how would the formula go? So sine A over
9
A
A
equals
sine C.
sine C over C. Perfect. Sine A is sine 59 over pyramid formula, it's gonna become more complicated, okay? So that's why we have to be careful what formula we're working.
Somebody look at
So that's gonna be 12 sine 59 over 19. And what would that give you guys?
this. One more yet.
So do it.
To the right.
Yes.
0.54.
And then you inverse sine.
Turn it on.
Inverse sine.
Go on, go on, go on.
Okay, so what do you get?
0.541.
And is that angle C?
No,
No,
it's
you
Not
gotta
yet.
go the
What do you have to do?
Inverse.
The inverse. All right, good. So remember that anytime I'm looking for the angle, I have to do the inverse. So remind me, what was the 0.?
5413.
Include as many decimals as you can when you're doing this, so you have an accurate answer, okay? And then you're gonna have to do your inverse,
Which is 33.
33
This
degrees.
is 136 in a miss.
Oh,
Sorry.